Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and Steelscape. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. As well, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam and junk folders. Now I'd like to introduce today's speaker, Michelle Vondran. Michelle graduated from California Polytechnic State University, San Luis Obispo, with a Bachelor of Science degree in chemistry. She started her career as a research chemist with Morton, later BASF, coil coatings with a focus on polymers. This position included lab development, lab to production, scale up, and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roof Rating Council and Energy Star Roofing program. She initially joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. She has held several positions, including Quality Systems Manager, Technical Manager, and now the position of Product Innovation and Technology. She oversees product and process development, product performance criteria, and warranties for NS BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. Michelle is an active National Coil Coaters Association board member, sitting on the technical committee, and a Zinc Aluminum Coaters Association member. In this webinar, Michelle will discuss how surface coating is the first line of defense in pre-painted metal and is one of the most important elements to consider when specifying metal roofing and siding. Selecting the right coating, finish, and paint system can affect product lifespan, energy efficiency, and aesthetic appeal. This course discusses the composition of pre-painted metal, its application, performance, and examines building and environmental factors that may influence the type of paint system specified. Michelle, we appreciate you joining us today. Please take it away.
Thank you, Stacy. Welcome, everyone. I hope you're all having a good day. A couple promises I like to make up front. Yes, I have a degree in chemistry. We're going to talk a little chemistry, but nothing too technical, and there will not be a quiz on it. So that's my promise to you. Click through a couple of these slides, the background information. Don't need to know anything ahead of time for this. Introduction level. We've got 4 sections here today. We will pause briefly after each section to take some questions, and then we'll have a time at the end for questions as well, because it's a lot of content to cover in an hour. So what is pre-painted metal? It's very self-explanatory. This is metal, usually coated steel or aluminum, which gets its paint applied in a factory setting before it gets fabricated into an end part for the construction industry. So these coatings have to withstand that forming and shaping process and installation process. So there's a lot of science that goes into that, but they're not all the same. So we're going to talk a little bit how this factory applied coating works and a little bit about the substrate before we dive deeper into the paint coating itself. Pre-painted metal or coil-coated metal goes into a lot of applications. Mostly exterior, but does get used interior as well. Exterior building products tend to be metal roofing and siding, gutters, rainwater goods, insulated metal panels, composite panels, roof tiles, and trim and flashing accessories. But we also do factory applied painted steel and aluminum for HVAC. Most of your appliances, kitchen type appliances, are coil coated as well before they're manufactured. Cabinetry, hot water heaters, door trims, ceiling trims, the T-bar that holds your acoustical ceiling in place, that's all coil coated or pre-painted metal. So pre-painted metal fundamentals and how it is applied. How is paint applied? We've got 4 options primarily: air brush applied, dipping, rolling, or straight brushing. We use a rolling technique, but not like rolling house paint on, a little bit bigger than that. So this is a kind of a typical generic coil line or paint line. They tend to be very, very long. Our lines, for instance, can hold up to 2,500 linear feet of metal from end to end, so they're big, typically 3 to 8 stories tall. We load the metal coil at one end. It's a continuous process, runs through the line, it gets cleaned, gets some pre-treatment, gets a primer, gets a top coat. Those are baked on at very high temperatures. These lines run anywhere from 100 to 700 feet per minute. From the time the paint is applied till fully cured and you're able to wrap that coil back up, it can be as little as 15 to 30 seconds. So very fast, very dynamic. So yeah, but this allows us to have a very good, consistent product as well. Right? So it's highly controlled. Everything is cleaned the same way every time. Everything's very automated. We apply the paint in a very controlled way each and every time. So if you order a specific paint today, you order that same paint a month from now, it's going to look exactly the same. You can intermix those coils. Very efficient. We're not applying very much paint at all. It's very, very thin. A typical paint system is 1.4 mils, so 0.0014 in thickness. That is thinner than a piece of paper. By comparison, most other industrial metal coatings, like for cars, powder coatings are 2 to 5 mils in thickness, so we're using a lot less paint. There are solvent-based paints, but we are capturing those solvents during as they go through the ovens and using that heat in a closed-loop system, so the final product is VOC-free. And again, this all happens before the fabrication, roll forming or stamping, whatever's going to happen to this metal. So this paint has to be very thin, it has to be hard, but also very flexible, and it's got to last on the outside of a building for 20 to 50 years without any change. But the size of how we do this and the fact that it's a continuous process does come with some limitations. Obviously, there's a scale of economy here. It's very rapid once running. We can't start and stop very often, so we can't run very small jobs, or we don't like to anyways. So you got to buy like a full coil. So we can do custom colors, but most coaters have like a minimum order for custom colors or something special. Typically whatever the line holds from end to end. So this can restrict the color palette a little bit, and can make it a bit more expensive or create much longer lead times if you need a short custom color. So quality control, we do a lot of quality control. The paint companies do a lot of quality control in the paint before it even gets to us. And then once we apply it, cure it, bake it on, we do a lot more testing. So the really important things are we got to simulate that forming and fabrication process it's going to go through. So we bend it, we bump it, we deform it. We check to make sure that paint is sticking and there's no loss of paint. We look, color is hugely important, right, in this architectural space in the world, consistently. So we are applying film between 0.7 and 0.8 mils consistently, tight color control within usually a delta E, which is a measurement of color of 1 unit or less, much less, which is not anything the human eye can pick up on. It is all, for the most part, computer controlled for color as well. It's numerically controlled. Gloss, kind of how shiny that surface is, that's also tightly controlled and measured on every coil. And of course, film thickness. Very critical for long-term performance. If we're not at the right film thickness, it's not going to perform out on the building the way it should, and that impacts warranty. So we have several different methods for checking that film and making sure it's consistent across the width of the coil and from end to end in a coil and from coil to coil. But I want to talk a little bit before we get into paint about the substrate underneath, because it's very important as well, and there's whole other presentations that get in depth on it. But most coated steel is either galvanized, hot dip galvanized, or an aluminum zinc alloy, more commonly known as Galvalume or Zincaloom, which are trade names for a 55% aluminum, 45% zinc product. Hot dip galvanized is 100% zinc. It's been around a lot longer, but both are used for exterior buildings. The Galvalume product does come with a corrosion warranty. That aluminum component gives it much better corrosion protection long term. So you can get a corrosion warranty on that product for most applications, not all. This is also done on a very large, much larger than our paint lines, continuous line. We call them metallic coating lines. So the bare steel goes in, it gets annealed to the grade of steel it needs to be, the physical properties that steel needs to have for its end use. And then we apply either 100% zinc coating or this aluminum zinc combination. This is a picture here of the strip coming out of the molten bath of metallic coating that it's getting before it's been dried and settled. It's very shiny. If you're buying 55% aluminum zinc product, probably want to make sure you go with someone who's AIA licensed. That is a licensed technology. You can't use the Galvalume name unless you have a license. I actually need to change this corrosion warranty. 2025 used to be typical. We're now seeing 40 to 60-year corrosion warranties on this product out in the field. So yeah, make sure they're licensed. You can go to the Galvalume website, see who the licensed producers are here in the United States and globally. It is a worldwide product. There are environmental considerations that will influence which type of substrate and coated steel you buy. Marine locations, heavy industrial, acidic conditions. I'm not going to get into too many of those details today, but it is something to keep in mind. So now we'll move on to paint. What is paint? We all know what paint is. We've all experienced paint in some form in our lives, whether it was finger painting as a child at school or painting our house or a car, or whatever that might be. It's a liquid, dries to a solid film. Usually it's trying to do two things. It's going to protect the surface of whatever it's going on, and we want it to have a certain aesthetic and appearance. It can be brushed, dipped, sprayed, vacuum coated, rolling. There's a whole lot of ways to do this. In our world, for coil coating and for exterior roofing and wall, which is what we're focused on here today, the primary components are resins, pigments, solvents, and additives. The resin, also called the polymer, or the binder of the paint, really dictates the physical and chemical properties of that paint system. It's kind of carrying the bulk of the load on its shoulders. We then have pigments, obviously very important for color and aesthetics, but also important for some protection and weatherability as well, which we'll talk about later. Solvents, like I said, these are all solvent-based paints. They've got to be in a liquid consistency at a viscosity that we can pump it out of a drum onto a coater head on a paint line and apply it. You don't want it to be too thick, you don't want it to be too thin. And then there's additives, which just fine-tune the overall characteristics.
Michelle, I'm going to jump in for 1 second. A couple people are having trouble hearing you.
Okay.
So they're asking if you could speak a little closer into your microphone.
I'll try. I'm kind of on top
Let's
of
give that a try.
Is that better?
Okay, let's keep going and we'll see if that works out.
Okay. So this is kind of a cheat sheet on the components of the paint and what they're bringing to the overall recipe or equation here. So the resin, the polymer, durability, hardness, flexibility, adhesion, gloss, chemical resistance, corrosion resistance, humidity resistance, impact resistance. That's a lot. It's a long list. Pigment, again, primarily aesthetics, but also hiding the substrate. Some corrosion resistance comes from the pigmentation in the primer as well. The strength of the film, some water resistance, of course, UV durability as well. And then the solvents, really not applicable to the end user, more important to the coater, but it's got to flow good, flow right, allows us to control the film. It's got to be stable, right? We want drums of paint that are going to last more than a couple months because we might run only part of a drum, put it back in stock, pull it out again later. So it's got to have the right solvent blend so that all that stays in mixture the way it should. This is kind of the percentage breakdown of a kind of a common everyday paint. Pretty evenly split between the resin, solvent, pigments, and then the additives could be up to 5%. Sometimes there's not hardly any additives in there. This is a typical breakdown. So how do you pick the right paint? It's a $1 million question, right? You have to balance all of these properties with how it's going to be used at the end. So For roofing, roll formed panels, it's got to be somewhat flexible and a bit hard, but not too hard and brittle. So this red line here is kind of where our typical exterior paints fall. They do lean a little bit to the harder side rather than too soft. So pigments, this is the fun part. This is how great it looks. These are insoluble particles. They're finely ground to a really small level and then dispersed within the resin or the polymer. And that needs to happen evenly so you get a nice even color. We use organic and inorganic pigments both. Inorganic pigments are metal oxides, usually things that are mined out of the ground. They're then fired at high temperature to make them very, very stable. They kind of tend to be your earth tones, a little bit duller yellows, reds, greens, browns, and blacks. Then you have your organic pigments. These are the bright primary colors, bright greens, bright reds, bright blues. They look great, but they're not very durable. I think we've probably all over our life seen older red cars that have faded, or bright colors that have faded on signage, or somewhere in our world. They just don't hold up very well to UV light. So the paint companies spend a lot of time making sure that these pigment ratios are good so that we can achieve the color we want, but are also going to perform long term because they're going to get a lot of constant sunlight. You may need a clear coat if you use a lot of organic pigment to help protect it more out in the field as well. And that's also factory applied. Color, we talked about color. Very, very important, right? Consistency, how it looks to the eye, very important in the design world. So we do measure the LAB system, which is light, dark, yellow, blue, red, green, numerically for almost every color we run. We can't do it on the metallic micas, but we can do it on all the solid colors. Most lines are running to a spec that's plus or minus 0.5 deviation on this LAB scale from the controlled standard, which is incredibly tight. The overall calculation is called delta E of color change or color difference from a control to your sample. The human eye really doesn't start to pick up color change until you approach a delta E of 1, and we're controlling much lower than that from run to run. The layers of paint, we talked a little bit about this. It's not just a single layer of paint. There's quite a bit going on here. So in your core, you have your steel or your aluminum substrate with your metallic coating. You then have a layer of pretreatment. This just kind of preps the surface to take paint, provides kind of a bite, point of adhesion for the primer that goes on. Put the primer on. The primers we're using all have corrosion inhibiting pigmentation in them because you're going to have cut edges and might have some exposure, so you want that protection there. If you're doing a job, we'll talk about severe environments later, but you can play with that primer to get a good product that's suitable for extreme conditions as well. Then you put your top coat on. If you need a clear coat, you would then put a clear coat on as well. We do paint the back side, the underneath of the strip, even if it's not going to get exposed or be seen in the final application. And we do that for a couple of reasons. It's often overlooked, but it plays an important role. It helps protect for corrosion once it's installed. It also helps protect the coil when you wrap it back up. If you had a metal-only side wrapped up in that coil against the top coat, it's under very, very high tension, and you can cause damage to the painted side. So you like to have paint against paint. And work is done to make sure that those two are compatible because they're going to be in contact with each other in coil form under very tight pressure. We can, most lines can also paint full colors, top and bottom, different colors on the same coil as well. It's not unusual to see. So if you have an application where both sides are going to be seen and you want one side to be one color and the other side to be a different color, absolutely doable with pre-painted metal. Okay, I'm going to take a pause here for any questions that there might be.
Okay, thank you, Michelle. We have some questions coming in, and just to remind everyone, keep sending in your questions. We'll be asking them again and at the end of the presentation. Our first question from Michelle: does the backer coat have the same life as the top coat?
Typically, no. standard or universal backers tend to be a lower end product and also not applied at full film thickness. It will have a primer, but it tends to be done at a half coat, tends to be a white or an off-white or a light gray for most applications. And yeah, it's probably more like a maybe a 10 to 20 year type product opposed to you might have a 40 or 50 year product on the top side. But again, if that backside is going to be exposed and you're concerned about its performance long term, have that conversation with your supply chain, because you can do a higher coating, you can do a higher grade coating on that bottom side if needed.
Okay. How do you control the batch to batch color consistency? Is color consistency better with an SMP or PVDF paint system?
No difference on paint type as far as color consistency. It's done the same. Uh, I'm gonna deflect a little bit. We rely heavily on the paint suppliers to do their job right. So they've got a lot of very tight controls in their processing to make sure that their batches are coming in the same to us every time. Again, controlling to probably less than a plus or minus 0.5 on the LAB scale. Most of the paint companies are using fully automated computerized dispense cells, so they're putting, really can fine tune their pigmentation and their final paint formula to us. So that helps. For us as the coder, it's about repeatability of our process, right? Duplicating roll settings, line speeds every time, hitting that film specification every time, and controlling that very tightly. And we really don't see too many color issues off the line. It's quite consistent. I've been around a very long time, unfortunately. Now I'm on the older side, but it's so much better than like 25 years ago. We rarely have pull-offs because of color anymore.
Okay, let's do one more question. Is it custom for two-sided painted surfaces? Is the second surface color the same as a primary surface?
Yeah, it's not common, but we do see it. But it's certainly not common. And again, as I explained, it can be two different colors. And that just depends on the final design and what the customer wants. I would say it being the same color on both sides is a bit more common than it being two different colors, but we can do it either way.
Okay, let's get back to your presentation.
Okay, so now we're going to talk about the different paint types. We just had someone mention SMP and PVDF. We're going to talk about that. Not all paints are created equal here and have different performances. So can you name the three common paint systems that we use? We have polyester, we have silicone modified polyester, and then we have fluorocarbon or PVDF, also known as Kynar or Hylar. We have a lot of names for that, unfortunately. But these are the three most common exterior building products pre-painted systems that we deal with. There are others out there. These are the three we're going to talk about today. Again, silicone modified polyesters, those are polyesters that have been enhanced. Fluorocarbon, I don't know why as an industry we have like 6 names for this product, but we do because we like to confuse everyone, I think. But fluorocarbons, PVDF, polyvinyl difluoride, there's a little bit of chemistry for you. I won't ask you to repeat it or spell it. Goes by the trade names Kynar 500 or Hylar 5000. You will see in the architectural specs for monumental type projects, big buildings, big commercial jobs, government jobs, PVDF or Kynar Hylar will be called out in the specs. So the paint companies have to be licensed to claim that their product is Kynar or Hylar. So that's a licensed technology. These are kind of listed in order here, typically from good to best, historically. Polyesters, workhorse of the paint world. Huge amount of variation in formulation, huge amount of variation in warrantability and what it's going to do. I like to remind people the chemistry family of polyesters. A polyester denotes the type of chemical link that's occurring in the polymer. So we're doing polyester paints. Some of us are probably wearing polyester clothing, right? Very different products, same base chemistry. A lot going on in the polyester world, but it's very cost effective They have great flexibility, but can also have great hardness. So there's a wide range there that you can formulate to. Really wide range of color and gloss. You can get very high gloss out of polyesters, more so than you can in the PVDF. Incredibly versatile. We see it mostly for lower end metal roofing. Polyesters are used extensively for rainwater goods, downspouts, light agricultural and commercial appliance wrappers. And then most of your interior products are going to be polyesters as well, because they don't need to have the exterior durability. But now, I will also add a caveat here that I would say in the last 10 or 15 years, polyesters have come a really long ways. You may hear terms like super polyesters. You may hear the term durable, super durable polyesters. There's recent polyester technology that has really bumped up its performance in an exterior setting, really pushing the boundaries of S&P, and has gained a lot of ground on PVDF. So they're out there. They come with pretty good warranties, but you might hear those terms, super and durable polyester combined. SMPs, again, silicone modified polyester. So if you react silicone into the backbone of a polyester polymer, it gives you better weatherability, better UV resistance, better resistance to shock. You still get a wide range of colors and glosses. It is lower cost than the PVDF. We see SMPs used a lot for residential and light commercial, both roofs and sidewalls. Again, this technology over the last 20 years has really advanced as well. If you're using really good inorganic pigmentation, both in the super polyesters and the SMPs, they're going to have outstanding long-term performance in the field, much better than they did, say, 20 or 25 years ago. Fluorocarbons, PVDF, Kynar, the Cadillac of the paint world for us, has exceptional resistance to shock and fade, holds up great in aggressive environments as well, both industrial and weather conditions like severe marine, has great chemical resistance, but also has excellent formability. So this is really the go-to product, carries the longest warranties, has the highest expectations on it. So big commercial buildings, monumental stuff, stadiums, high rises, military jobs are going to call out fluorocarbon or PVDF. Also gets used a lot for high-end residential as well. So we do see it there. It's kind of the best of the best. So again, a little cheat sheet for you guys, kind of a reminder of where these all sit. Again, polyesters are becoming tough because such a wide range. It's hard to just kind of shove polyester into one bucket. But in general, good to better type system, very cost effective. Warranties can be anywhere from none to, I've seen some 25, 30-year warranties out there on polyesters. Durability, again, can range from limited to very good, very versatile. I do have the AMA specifications listed here that govern each one of these. S&P sitting in the middle, good workhorse, good for just about everything, wide range of colors, a little bit more cost effective than the next step up. And then PVDF is kind of the best. So high-end warranties, seeing warranties typically around 40 years for PVDF currently. So what do we want to consider when you're picking your paint, right? Because again, they're not all the same. And, a polyester from one supplier may not be the same as a polyester from another supplier as well. So you got to kind of look at the technical data sheets, look at the warranty, to see what the performance is supposed to be like. So especially in polyesters, again, because of that wide range of formulations, they're not all the same. The differential, however, from high-end polyesters or super polyesters to S&P are kind of marginal anymore. PVDF still offers the best UV resistance and optimal exterior durability. Reminder that Kynar 500 and Hylar 5000 are a trade name for PVDF. You got to be licensed. The paint companies have that license to call it that. And again, the PVDF system is the most durable when it makes up 70% of the overall resin. So we talk about resins and polymers being the workhorse. In a PVDF system, 70% of that polymer will be the PVDF resin. The extra 30% will be an acrylic, which is used to keep it soluble and then help with cross-linking in the front of your paint. Pause there. Questions?
Okay, we've got some good questions coming in.
Okay.
First question, why do we have a 40-year SMP, but Kynar is 25-year?
I can't answer that. I can only speak for my organization. Our Kynar warranty, it's not 25 years, it's longer than that. So it kind of depends on each panel manufacturer and what they want to take to market, right? So, I mean, it really is a bit subjective. And a bit of it is a marketing tool, but there are longer warranties on Kynar out there than 25 years.
Is the standard backer paint made from a virgin material, or is it often made from recycled or secondary product?
It can be both. I cannot speak to the percentage of virgin versus recycled, but both are available and both get done. The way our process works on these coil coating lines, we typically end up with about 5 to 10 gallons of leftover paint from every run. And these are very expensive paints. I mean, they range anywhere from $25 to $200 or $300 a gallon. So these are expensive paints. We don't want to throw any away if we don't have to. But yes, there are paint companies and coaters who do recycle their paint and blend it into backers or other products when they can. That does happen. But same performance, a lot of tight controls around it. You can't just throw anything in that quote recycled paint. It is controlled like it's a new batch of virgin paint for performance purposes.
Does a factory paint coating on Galvalume add significant life expectancy over just factory Galvalume coating directly when it's directly exposed to the weather?
It can. Yes, certainly, it certainly can. And you will see that most of the Galvalume warranties now are written based on whether it has paint or not on it. So yes, you do get some extension of life with that painting. And then it also depends on what kind of paint you put on it too. So Galvalume in and of itself, bare, used unpainted, has a very long life, probably 40 plus years. We've got buildings out there that are coming up on 60 years old that still look good with no paint on them. But yes, adding paint does extend that life and that warranty in most cases.
Okay, let's do one more.
Okay.
What can you do to restore a metal roof whose color is chalking?
Oh, yeah. There are field painting options available. There are some really good field painting contractors out there, and they can come and power wash or sandblast the old coating and then apply, either a new primer and top coat or just a new top coat. That technology ranges quite a bit. There is air dry PVDF available, air dry Kynar systems available that usually come with like a 10 or 15-year warranty when they're field applied. So that is an option to go in and refinish. You can, depending on the construction and the panel type, pretty easy to repaint in the field and get another 10, 20 years, as long as there's no corrosion or other, degradation happening. You can paint over these factory applied coatings if you know what you're doing.
Okay, keep on sending your questions in, and for now, we'll get back to Michelle's presentation.
Okay, we're going to talk about enhancements for pre-painted metal, kind of the fun, special stuff we can do. So, what's the important things to consider when you're speccing pre-painted metal? It's a long list. These are the top ones. Proximity to salt water, anything corrosive, we're going to talk about that in depth. Energy efficiency, does it need to be a cool coating? How cool does it need to be? There's specs out there. LEED, of course, has got criteria for this. A lot of the Southwest states and counties and cities have cool definitions in their building codes. The desired color, how visible is this building? Where does it sit in its environment? How much light and glare is reflecting off of it? That's kind of important. What other materials are you going to use with the coated metal? You got to make sure those are compatible and they're used correctly so that everything lasts as long as it should. Do you have exposed eaves? Do you have sheltered areas? What does maintenance look like? So we're going to hit some of the highlights. This is not the full list of possible enhancements, things we worry about, but it's the top ones. The first one is special effects kind of pigmentation. Mica is a metallic pigment, so we tend to refer to these as metallics because way back when it was actual aluminum or copper flakes that was used in the pigmentation of these systems. We now use mica or pearlescent pigmentation to get the same look. So these are your silvers, your champagnes, your copper pennies, those kind of colors are done with this special pigmentation. Clear coats. Clear coats can be used for a lot of different reasons. We talked about organic pigmentation earlier. If it's going to be susceptible to UV fade, you might put a clear coat over it to help it, like all cars have a clear coat over them to help that paint stay good. But you might use a clear coat for graffiti resistance. You might use it because you're in a corrosive environment and you want some extra protection. So a lot of different uses of clear coats. Marine and industrial enhancements, we'll dive a little deeper into that. Play around with your primers, some of your top coat configurations to get better performance in severe corrosive environments. Graffiti resistance is available. Cool roof pigmentation, that's energy efficiency. Textures have become really big. Textures and matte finishes, killing that shine or glare on pre-painted metal. We're seeing a real movement towards that, especially in the residential space. And then prints and imagery, very fun stuff we'll talk about. It's gaining a lot of ground. So the micas and metallics, again, mica pigment is added to the paint like any other pigment. Give it this kind of sparkle effect or this pre-pearlescence color. We still call them metallics, even though they may not be metallics. Very light catching. You can also get the color shift pigments. We see that more in the automotive world. You guys have probably all seen wraps or paint jobs on cars that might look purple from one direction, green from another. That pigmentation is available in the coil coating world as well. I haven't seen it used too often. The project I see most, because I'm here in Southern California, is the cruise ship terminal in San Diego has a color shift pigmentation on it, and that was all done on pre-painted factory applied metal. Micas, some words of cautions around micas and the metallics. These are not consistent from batch to batch. You need to run your entire project out of one run off of a coil coating line because these are very hard to control color and look from batch to batch, from the paint making all the way to the application. So they are what we call batch sensitive. Cannot mix batches on these. There's no guarantee that they're going to look the same. There's also directionality to these pigments. So the way that the coil is running through the line in the direction of the roll coating affects the appearance. If you take a panel and turn it 180, it'll look different. So the picture on the left here, all from the same run, they reverse those panels. So you see that slight color shift. Same on the right, a little bit less obvious, but those are panels that have been turned 180 to the ones next to them. So you see that difference. One way to combat this is to make sure that your coater puts directional arrows on the back side. You can put arrows on there so people know what direction it's supposed to be going. And then the strippable film that the panel manufacturer uses, they can put arrows on that as well, so everything gets put in going the right direction. Extreme environments is probably the one we deal with the most. We have a lot of coastline here in the United States, some of it pretty severe. So they can be modified. You can get warranted product right along the ocean if you use the right paint and right substrate. So typically includes high build primers. So we take those primers and either use special formulations and then also apply them at a thicker amount of primer to help beef up that protection. Also might need a clear coat as well. It's going to be 3 or 4 coat systems to get you a warranty where there's breaking surf. The caveat here is that the definition of marine location is not consistent in the industry. So I try to tell everyone, if you're within a mile of the ocean for your project, have the conversation very early on about what type of paint system you need, because I see marine defined as everything from 1,000 feet from salt water to 1 mile from salt water. So if you're within a mile, check with whoever you're going with for panels who's going to be supplying your project to make sure that the right paint has been specified and applied so that you can get a warranty, and then ask what that warranty is. It's typically not as long as regular product, right? PVD, and this is going to be a PVDF system for marine application. Like I said, PVDF warranties now are anywhere from 30 to 40 years typically, but you could get typically 20 years with a high build system next to the ocean. It's pretty standard. Again, clear coats, what we can do with clear coats. Graffiti resistance is a big one, helping protect organic pigments. When it's used for anti-graffiti purposes, that it's a special clear that does two things. Not only is it really hard to get other coatings to stick to it, so it's hard to get the graffiti or the tagging to stick to it in the first place. If it does stick, it cleans off very, very well, much better than a typical normal clear coat or paint system. And then you might also use clear coats to increase hardness or mar resistance, food staining or contact. There's kind of some niche markets for some clears out there. Caveat on the clears. We call them clears. Not completely clear. They have a very slight yellow undertone to them. That's because they have translucent UV barriers built into them. It gives them a little bit of a yellow cast. So on lighter colors like the white on the top, it's a standard product on the left, just primer top coat. The middle panel has high build primer, no clear coat. The panel on the right has high build primer and the clear coat. And you can see that there's a slight shift in that color as you move left to right. But that's on a white. Once you get into your mid-tones and dark colors, like the red on the bottom, it's the same thing. Regular product, high build primer, clear coat. The eye can't see any difference there. So it's minor. If you're using a light color, you need a clear coat, and that yellowing is a problem, then you can have a conversation with your supply chain about adjusting the color of the color coat to counteract that yellowness. Backers, we had a great question, several great questions about backers, kind of the unsung heroes. They often get overlooked, but they're necessary. They're often unseen, but not always. They are typically some kind of neutral color, an off-white or a light gray. But again, although we apply them typically at a half coat, we are still controlling them very tightly because we know that on an overhang on an eave, the inside of a pre-engineered building, you are going to see that backside. You do want it to look consistent, look the same from panel to panel. And again, we talked a lot about we can't do double-sided. Cool colors, right? So this was cool pigmentation introduced about 24 years ago now. These pigments were altered to reflect more IR energy, but look the same in the visual range. So we kept the visual color the same, but got it to reflect more heat and not get so hot in sunlight. So this allowed us to get dark and mid-tone colors that were, quote, cooler than their traditional counterparts. So any paint system can use cool pigmentation. It's not limited to paint system. And most of the coil coating suppliers are using cool pigmentation as their normal default now. Doesn't usually have to be specially requested. It's kind of the norm anymore. But it can greatly reduce heat buildup. Then you're not using as much AC, less energy. Helps with heat, urban island effect as well. And we all know how much hotter everything's going. I saw an article today, 2024 will be the hottest year on record since we started tracking this stuff. So pretty important. There's a lot of terminology, though, around cool pigmentation that can be a bit confusing. So the standard terminology we use for cool pigments is solar reflectance. That's the amount of solar radiation reflected off of the surface. The emissivity, this is the amount of heat a surface dissipates away from itself. Those two values are used in a very long, nasty calculation to come up with the solar reflective index, or SRI. This is what you'll see in LEED and in building codes. And then you come up with this SRI value. The higher the number, the better the thermal performance of this coating. So lighter colors still have an advantage, but you can get some mid-tone colors that are pretty darn good as well. Most panel suppliers will have this listed on their color cards. This is an example here. The Cool Roof Rating Council is kind of the third-party independent entity that keeps us all honest on this, and you can certify your product and get it listed with them. They also do aged performance, 3-year aged as well. Pre-painted metal does incredibly well. High-end paint systems pre-painted through the coil method will have little to no color fade until like year 20. So their thermal properties, their solar reflectance, is not going to go down like other materials might. It's going to hold those really good values for a very long time. Here's green building. A lot of you on the call are probably much more familiar with this than I am. This is the current. I know we're about to have version 5 coming out. But they break it down: low slope, steep sloped roof, and what the initial SRI needs to be, and then what the HSRI needs to be. Again, your panel suppliers should be able to give you this information. Now this is where it gets a little confusing. Now we have gloss and sheen. Gloss and sheen are the visible shine off of the surface. Gloss is measured at a 60-degree viewing angle. Sheen is measured at an 85-degree angle. We have instrumentation that does this for us. High gloss, high sheen results in a high glare from a surface. Low gloss surfaces will have a more matte appearance. Low gloss, low sheen systems will have a very flat, almost no reflection of light off of the surface at all. This is different than solar reflection. You can get cool pigmentation that has a very matte, low glare look to it. They're not tied to one another. This is also different than light reflectance value, which measures kind of the light-dark spectrum that a color is on. So they're all different, not necessarily connected. I have run across some building codes where they've gotten this confused, and they're equating low light reflectance with low solar reflectance values, or vice versa, and that's not true. So there's quite a few technical bulletins out there to try to keep this straight for everyone. Again, you can lower the gloss a few ways. You can do it chemically, but with how the polymer reacts. You can do it with pigmentation. You can do it by actually putting textured, granulated, actual physical particles in the paint to give it a rough textured finish, which doesn't allow light to reflect back off of it. So flattening agents, textured finishes, ultra matte finishes, again, becoming very, very popular because they look more like a natural substance rather than painted metal. The panels here, this gray color in the top photo, those are numerically the exact same color. One has no gloss or sheen, or less than 5 gloss and sheen, and the other one has a standard kind of 20 gloss on it. And that's visually how different they look, even though they're the same color. Same with the blacks. You can see here the LRV is the same, vastly different gloss, vastly different sheen, almost identical SRI properties, right? So very different look, same cool properties, very different finishes. And then the fun part, this is where it gets, I wish we could spend more time on this. Prints and decorative coatings. You don't have to have a solid color. A lot of lines can do print and digital printing now. These are rolls that have been etched or carved to give that print pattern. You can do different color combinations. It may have one print pattern, it may have two. It can look like wood grain. It can look like patina. It can look brushed. There's a lot of different effects you can do. Development time is relatively short. You do have some limitations because there's going to be a repeat on the pattern based on the size of the applicator roll that we're using in production. But yeah, really popular. It's a neat look. And now we're getting into digital printing as well, which is the picture here. So you can actually print imagery with not much of a repeat. I think they can go up to 30 feet before they repeat, and get some really cool looks as well. There's also laminates. We don't see as many laminates in the US as we do overseas, but this is an image that's been printed on a film, and then that film is bonded to the substrate. Doesn't have great durability or UV resistance, and is used more for interior applications, doors, some garage door work. Don't really see the laminates being used for roofing and siding so much. That film bond is not as strong as actually factory applied paint directly to the surface. Okay, I'll pause quickly. We do have time. One or two questions, right?
Yeah, we'll do a couple questions. Do backers have the same performance as materials coated with color on the back?
Depends on your backer. No, standard backers, are not going to have the same durability as a full coat system on that bottom side. There will be a difference.
For PVDF coatings, are darker pigments naturally still more UV resistant, or is that not so much the case?
Yeah, I would say darker. Your blue and green, red pigments tend to probably be a little bit less UV resistance than the browns, the blacks. some of the other colors, but I mean, it's a minimal difference. We're going to talk
Can
about
you,
constructs. Most color fade that's allowed is 5 units over the course of a warranty. So 5 units of color fade is quite a bit, and it's not different because of whatever the color was. The paint companies don't treat those different pigments differently for warranty. So, I mean, they're all going to fade about the same at the end of the day. And you got to understand that most paint formulas, almost every color that we run is a mix of at least 3 to 5 different pigments blended together. It's not just one pigment. It's a combination of pigments in every formula.
can you elaborate on repeatability of the roll?
Okay, so, right, our rolls depends on the paint line, but the roll that the paint goes on and then touches the strip is a certain diameter. So typically anywhere from 8 to 10 inches in diameter. So if there's a pattern on it, that pattern is going to repeat based on whatever that diameter of that roll is. So we have to be careful about the pattern because you don't want to put finished panels up that are 20 feet long and see this repeat, right? You don't want to see this, consistent repeat of the pattern. So we, keep that in mind. Now with digital printing, that's a bit different. Digital printing is like a giant inkjet printer almost that goes on a paint line. And can print up to 20, 30 feet of image before it starts over again. It's a little bit different technology. Very, very new technology. Still kind of being fine-tuned. The warranties are not quite there on the digital printing yet that it is on traditional paint systems, but they're getting there. So that's the repeat I'm talking about. It's dependent on your so for instance, if you were doing a wood grain print traditionally with a traditional applicator roll, if you had a knot, right, a wood knot built into that pattern, it's going to repeat in the exact same place every few feet, right? So you kind of want to you don't want to have that, right? So we engrave these rolls to kind of minimize that repeat pattern as best we can.
Okay, let's get back to it and we'll take a few more questions at the end.
Durability and warranty. What are the 3 common elements warranted by a pre-painted metal product? Corrosion performance, we talked about that the Galvalume substrate comes with a corrosion warranty, usually. And then the other ones on the paint side are film integrity. That means, is the paint going to stick? Does it have good adhesion long term? And then chalking and fade. It's usually what's written into a warranty. So again, these can extend from 5 years up to 40 years. Going to warrant for excessive chalking, excessive color fade, and delamination of the top coat of the primer to the substrate underneath. A lot of things that can affect this. The paint formula itself, was it applied properly? How was it handled and installed? What are the environmental conditions it's been exposed to? And then, of course, the different paint system types that we talked about, poly, SMP, PVDF, all kind of have a different warranty. This is a really old study. Technology's come a long ways, but it just kind of shows you how there's a Kynar 500 of polyester and a silicone polyester in 1981, same starting color. Fast forward to 1995, and you see how vastly different they are performing against each other. So that's color fade that we're talking about. Excessive chalking. I don't actually see this very often anymore. Paint technology has gotten really good at minimizing this, but this is a degradation of the resin or the polymer system itself, kind of breaks down into little smaller bits and pieces. Those little bits and pieces now can come out of that coating with some pigment on it. And we call it chalking because it looks like chalk. It's white. You run your hand on it, your hand's got this dusty white stuff on it, caused by UV rays. The higher end paint systems like PVDFs, high-end SMPs are not. I mean, it's rare for them to chalk. You just don't see it, but they are warranted for 20 years plus usually for that. There is an ASTM method for measuring this. It's a little bit subjective. You take a black rag, wipe it on the surface, you compare it to some photos, 0 to 10 scale. The higher the number, the better on this. So 10 means there's no chalking, and 8 means there's very little chalking. So that's kind of how the scale works. You want a higher number on this. Color fade, this is the big one that we see claims for. So again, the pigments are breaking down. We measure it by delta E. We've talked about that a lot. So that's a numerical value that represents total color change from its starting point. The human eye starts to see that between 0.5 and 1 delta E. PVDF systems warrant the smallest color change. So inside a warranty. The headline might say 30-year warranty. Okay, great. But how much color fade are they allowing in that 30 years, right? So you got to look at that number that they've specified. Is it a delta E of 5? Is it a delta E of 7? Is it a delta E of 8? And again, the bigger number, the more color change that there could be. I've got some samples here. They're not great on the screen, but starting at the top is where the color started, and then a 5-unit color change, and then a 7-unit color change as you move down. What's more important out in the field on a roof is that it fades evenly. If your roof panels, siding panels are all kind of fading evenly 20, 30 years down the road, usually no one really notices or cares. But if you get a few panels that look different than the others, that's usually when we get a phone call to see what's going on. This can be due to a couple of things. We call these candy cane striped roofs when we see them. A couple things can be going on here. It could be a difference in film. Maybe the coater didn't put enough film on some of these panels, so it's weathering different. It could have been that 2 different paint systems were mixed on a roof. I have seen that. I have seen an SMP and a PVDF, they're the exact same color, get mixed on installations, and they weather differently over time. It could be a mix of paint suppliers. Again, I talked about not everyone's paint's going to weather the same. They all have slightly different formulas, so you cannot mix paint vendors on a project, even though the starting color looks identical. So you might get differential performance over time. Delamination. This is a tough one. Why is the paint coming off? And unfortunately, I've listed 5 possible root causes. There's actually about 400 root causes for this. It's a tough one to investigate. But this is a loss of paint, either top coat to primer or the entire paint system, including primer, coming off the metal underneath. Maybe bubbling, peeling, it might be chipping or cracking. Low film is often a cause of this. You don't have enough film on there, so that UV is penetrating and breaking down those bonds. The paint comes off. Maybe the pre-treatment underneath wasn't good. Maybe the substrate wasn't cleaned well before you painted it. Maybe it wasn't cured right. This is fun. If you under-cure it, or if you over-cure it, you could have the same mode of failure in the field. That's a fun one. Incompatibility between top coat and primer. But the one we probably see the most, which is a tough one for building owners or homeowners, is mechanical damage. So the panels got damaged during installation or during their life, a scratch, a tear in the paint for some reason. You now have an opening where moisture, ice, debris can get in there. It just kind of starts that picking off process that happens with paint. And once you've opened this paint system up to that, it can go pretty quick. Other avoidable failures and things we caution about is, again, using other materials with the pre-painted metal. So dissimilar metals, galvanic corrosion can be a problem. Not all metals are compatible with each other. Using the right sealants, SOR for metal filings. These are filings from cutting or drilling on a site that are left on the surface and embed in the paint, and then that rusts. The panel itself is not rusty, but those little debris pieces are rusting. Wet stack, this is storage. This is corrosion that can occur on these panels while they're waiting to be installed and they're sitting in bundles somewhere. And then oil canning, not a failure, but I like to bring it up. That's kind of the buckling or wave you might see in some standing seam type roof applications. Dissimilar metal is a big one. I know we're running tight on time, so sorry, I'm going to go really fast. This is really an issue around marine settings. So if you're in a corrosive environment near salt water, the biggest ones we see is stainless. Stainless is not compatible with hot dip galvanized or galvalume product next to the ocean. The galvalume or the galvanized is going to sacrifice itself for the stainless steel component. And what it does is it actually corrodes underneath the paint. So the first indication that something's going on is your paint is bubbling and lifting. This is a stainless steel lighting fixture recessed into a galvalume panel with no barrier between the two. So in direct contact, about 200 feet off the surf break outside of San Diego. And this corrosion developed within a year or two of installation. It's quite fast. If you peel that paint back, you will see that there's actually corrosion down to base steel occurring underneath. The paint is coming off because there's nothing left for it to adhere to anymore. Wet concrete, got to have a barrier. Wet concrete against the edges of this coated metal causes corrosion issues. Again, the paint starts bubbling off is your first indication. Chemically treated wood can be a problem. They're usually treated with copper compounds, and copper and pre-painted metal don't get along very well. This is Pat Benatar's house on Maui. This is a copper-treated deck that was dripping onto the painted metal below. Corrosion where that runoff was occurring. As soon as you got past the deck, the panels were fine. Swarf, the big one. New installations, we'll get a call within weeks of installation being finished. My roof is failing already, it's corroding. Probably not. But these are little debris from this fastener that was drilled in that they didn't clean off afterwards. And those little pieces are now rusting and leaving a stain on the painted surface. It's an aesthetic issue, typically not a performance issue, but if you have a brand new beautiful roof and it's got all this staining on it, you're not going to be very happy. The picture on the bottom here is one of the most severe swarf examples I've ever seen in my life. I mean, there's just metal shavings everywhere that they didn't clean off. And now that stain is there. It's very, very hard to get rid of. There's a lot of technical bulletins from most panel manufacturers on how to cut properly and how to clean up properly. It's really not that hard if you follow the instructions. Wet stack. This is corrosion that occurs when the panels are stacked together. It can happen in coil form too. So if moisture gets in there and there's not a lot of airflow, that moisture works its way down to the interface between the paint and the substrate and causes corrosion to occur kind of from the inside out and pushes the paint up. Often looks like these little fine blisters or bubbles on the paint system. There's a lot of, again, technical bulletins out there on how best to store product so that this does not happen. Oil canning, buckling. You can see the buckles on here. It's a great example at the bottom how to get out of it. So a long span, 20 plus long panels, this is going to be more predominant. If you put a styration or a pencil rib in the forming, it takes that away. Lower gloss material hides this too. It's still there, but because you don't have that shine off the surface, it's really hard to see it. So matte finishes tend to hide this. This is just an inherent nature of light gauge steel being used for roofing panel. So how do we avoid failures? Right paint system for the right application and location. Use a good coil coater, knows what they're doing. Don't mix batches if you can avoid it. A good product manufacturer that knows how to package their product, knows how to protect it before it gets to the job site. Good installers know how to install properly and use other materials properly. And then cleaning. You need to clean it. You clean your car, you wash that paint system off. You kind of want to do the same for your roof, your walls. And with metal, it's really easy. You kind of just need a good high pressure hose and you can rinse it down. Doesn't take a whole lot. Again, warranties. Don't get caught by the headline. It says 40 year, it says 30 year. Read in through the first few paragraphs at least to see what are they warranting for that time period. How much color fade, how much chalking, what are the limitations around marine settings and industrial. A little boring. They're typically one pagers though. Look and see what the exceptions and exclusions are. Just don't go by the headline duration. Good, I think we covered this. I know we're running late. Okay, I'm going to stop. I'm going to read this. You guys can read this. We'll take some questions if anyone's still hanging on with us.
Yeah, people are hanging in there, Michelle. We've got a couple more questions. For example, can roofing, siding, and gutters be from the same batch such that fading is consistent?
Absolutely. Yep.
Okay, one more question. If the metal is scratched, dented, or exposed, is there a treatment to prevent further corrosion?
Yeah. If the paint is scratched, and it's a light scratch and it's not throughout, it's just a little scratch here and there. There are field touch-up air dry pins, color match to these systems you can get and just lightly touch that up. If you can't see it from a couple feet away and it's not very deep, our recommendation is often to just leave it alone and not mess with it. The problem with the touch-up paint and the field applied paint is it's not going to weather the same as the factory applied paint. So you want to be very careful doing touch-up paint in the field. We recommend that if the scratch is heavy or there's frequent scratches, you need to replace a panel. Dents are not usually problematic. I mean, as long as the dent didn't cause a fracture in the substrate or the paint, might be an aesthetic issue, but it's not really going to be a performance issue. So it kind of depends on where it is and how visible it is. And, most people can't see a full roof from the ground. So if it's not causing an aesthetic issue, just leave it alone.
Okay, let's take one last question. With the stainless light fixture, could you have placed a rubber between the light and the metal panel, or is this the fastener causing the galvanic action? What methods can we use to isolate, because we can't always spec fixtures that are the same metal as the roofing system?
The direct contact is key. So yes, they could have put something in between that, so there was not the direct contact. And I've seen that with fasteners and stuff too. If there's not direct contact with the stainless, you're probably going to be okay. I've also seen coated stainless, so the core of the fastener is stainless, but it's got an enamel coating or a zinc coating over the top of it. That tends to be okay too. But yes, that issue with the light fixture could have been avoided if the installer had kind of read up a bit on what he was supposed to do. Ironically, that same house was the same one that was in the concrete example as well. There was a lot of installations issues there. But yeah, the direct contact is key. If they're not in direct contact, you're going to be okay.
Okay, that's all the time we have for questions. Michelle, if you want to put your contact slide.
Oh, yes. There I am.
If you need to reach out with any additional questions, Michelle's contact information is up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered within a week. As well, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us serve your needs in the future. Thanks again, Michelle. Thank you, everyone, and have a great day.